Let me check. Okay. Okay, good. Okay. So I'm going to dedicate this particular lecture going back to one of the most important programming language design principle in C++. So this is about virtual function. By now, you probably know how important virtual function is, because it's a C++ way to implement the concept of polymorphism. So let me remind you about what is a virtual function. So the difference between a regular function and the virtual function is that for the regular function, the exact function I'm going to call is actually going to be determined at the time or exactly the place where you call the function, which is basically the compiler at compiler time is going to put a link about that piece of code to another piece of code. Usually is some kind of call or jump pointer, so they can call that function. So that's a regular function. But virtual function is different. Virtual function is exactly what function is going to be used to be called is going to be determined at the time the object was created. So there are two things. One is exactly the place where where is exactly the function call. So that's a regular function. Let me put it here. I mean, this concept is kind of complicated, so I sometimes stumble myself. Is in the program exactly the location of the call itself. And this is a determined at the compiler time. However, when you have a virtual function, it is at the time the associated object was created. Okay, this is interesting because I'm actually going to write a piece of code which has the format of object x dot this function I call a foo. Okay, so what I'm saying here is that, well, it determined at the time the object x was called. Instead of looking at just the location of the call, I decide. So that's actually pretty interesting because I don't know when or where the object x was created, because I might have a bunch of objects, object x, object y, object z, and they basically kind of call by reference or whatever way, it actually go into this location, object x, as a variable. So I have an object iPhone, object Android, object Raspberry Pi, object whatever, right? And then the thing is that exactly what is a foo, it depending on what is object x, and more importantly, at the time the object x was created. So this become a challenge for compiler because compiler has no information in general to actually know this piece of code is actually going to bound to which creation, because there are so many creation. In fact, I can show that some of the creation might be remote if you blended the virtual function together with remote procedure call. But that's not the point. The basic idea is that virtual function is a concept is really depending on when the object was created. Okay, so that's the fundamental issue about virtual function. I hope you remember that's probably one of the most challenging concepts in the C++. Okay, now I'm actually going to dedicate this lecture to the following issue. So given that we assume we remember what is a virtual function. And this issue, in fact, if I'm going to interview a C++ programmer, I'm going to ask the following issue, because the following issue is going to kind of differentiate somebody who is understand the C++ at the service, or somebody really understands C++ into the bone. Okay, so I would say, how does C++ implement the concept of virtual function? I mean, how does this really implement? I mean, essentially, I'm saying that, well, you have this virtual function, you have this object X, and I have to determine exactly which function to call. I have to determine to retrieve some information from at the time when the object was created. So the thing is that we know how to use it as a virtual function. We know the semantic meaning about what virtual function is. Hopefully, after you write a few application programs that involve virtual function. But more importantly, why we kind of keep saying that this is a compiler time and this is actually runtime. And how does that work? How can C++ as a programming language can really implement the concept virtual function so we can enjoy the semantics provide? So that's what I hope to cover this lecture, but I need to use the idea of multiple inheritance versus virtual inheritance to do that. And important thing is that one of the things you need to learn is, in order to understand this, you have to understand the concept of vTable. Some of you probably already heard about the idea of a vTable. And today we're going to look at what is a vTable. In fact, because of this vTable is the data structure that will allow us to support the concept of a virtual function. And vTable can support other stuff as well. But one of the most important thing is the virtual function. Okay, all right. So let's actually take a look at the following piece of code. Okay, so I'm actually going to show you two pieces of code. They have exactly the same structure. The first piece of code I'm going to show you is, let me actually give you this piece of code. Let me make it a little bit bigger. So I have a class called core. And the core has only one attribute, which is host URL. I'm actually making host URL double. It looks kind of strange, but to simplify the whole experiment, it's probably easier to say, hey, I have a host URL at the core, which is a double. And then I have a person object, which is inheriting. This is a single inheritance, by the way, to that core. Okay, person core. And this person has only one attribute called social security number, which I also included as a double because I want to make everything 8 bytes. So for me to illustrate, okay. And then I have another variable, another class called thing, which is also inheriting from core. So basically both thing and the person, they actually inheriting from the core. And the thing has also a variable called sequence number. So we have URL, we have social security number, and we have thing. And finally, I have a class called robot. And the robot is multiple inheritance to both thing and person, and has something called robot number. Okay, so let me actually go back to my PowerPoint slide. So it's a very simple 4 classes with an inheritance hierarchy. Looks like this. Okay, I probably should let me actually change this a little bit. So it's the same thing. Okay. So this top is core. And this one is person. Okay, I'm not sure is a good idea to consider robot as a person, but let's, for the purpose of virtual function or multiple inheritance, I will use this kind of controversial example. Okay, so I have this inheritance hierarchy: core, person, thing. All right. Any question about the code I show you and the inheritance hierarchy looks like this? Okay. Okay, so no question? Okay. So I'm going to ask you a question, is that which of the two is the correct way of inheritance? So I actually have two different ones. So now you can see that I didn't change. I use account, employee, student, and work study student. Okay, so this is another hierarchy. I have an account. I have a one class called employee, one class called student, and I have another class called work study student, which it has multiple inheritance from both employee and the student. So now I'm actually having two different ways of drawing the picture. The difference, by the way, is that the top hierarchy has two copies of accounts. And the hierarchy I drew earlier and the below, assuming this particular object, work study, has only one account. So let me actually tell you that in real scenario, you might have this. For example, what kind of account it is? If the account is an email account, right? If it's an email account, then essentially a work study student, regardless you're an employee or you're a student, you actually use the same email account, right? You don't need to use different email account, one email account for employee, a student, you don't have to. I'm saying that, yes, in some case you want to. So you can actually share an email account among inheritance hierarchy. Or on the top, I can say, hey, this is your financial account. So you have an account related to your salary as an employee. You're actually receiving salary, and then you have that. But you also have an account for your tuition. You have to pay the bill, pay the university for be able to obtain your degree, which is you have a different account. And then the university might actually probably have a separate account. One associated with purely the student, one is associated purely as an employee. Okay, so you can see that in this kind of simple design, the code is actually on the right. You can see that I have this inheritance hierarchy from account to employee to to student, and then work study inherit both from employee and the student. Okay, so we have two possible scenarios. Okay, first, let me ask you, do you see the difference between these two? The difference between these two. I'm not saying which one is the corresponding correct inheritance hierarchy according to this code. But I want to tell you, first, we understand that for four classes have this kind of inheritance hierarchy, means four class here is account, student, employee, and the work study. The relationship between these four classes has this two different way of doing inheritance hierarchy. I want you to see the difference. And the difference is that the one has only one account. They share account, and one they actually have a separate account. So if I draw it, it looks like this, okay? And similarly, you can actually do this as well. For example, this one, you can actually have a core looks like this, but then you can have a two core, one for the core for the person and one core for the thing as well, right? You can have that. Okay. So let me ask you any question. Okay, let me then ask you if you understand the difference So my next question is that if I want you to choose the way you want to do with multiple inheritance. So what is a multiple inheritance? Multiple inheritance means that a class that's simultaneously inheriting from two bases, which is in the case of the work study, that it inherit from employee as a base number one, and it's actually student as a base number two. So it simultaneously have a multiple base. So single inheritance means that every derived class can only have a one base. So multiple inheritance, you can have a multiple. Okay. Okay. So my question for you is that based on your understanding about multiple inheritance, at least conceptually, not programming wise, which way do you think is more appropriate? This way or that way? The top or the bottom? Which way do you think is what you believe before you take this class, or what do you believe when you have inheritance from other programming language such as Java or C or Python or whatever object-oriented language you have? So when you have an inheritance, which way do you think is the right way to do multiple inheritance? It's a very tricky question. No standard answer. I just want to get a sense from you about what you have been thinking before you walk into this class. Okay, let me do. Yes. Yes. Thank you. This one looks more efficient, and that one is there are some application number one. But yes, that's how C++. So thank you. So number one, I want to say is that in fact C++ actually support both, but the top is really called multiple inheritance. The top is called multiple inheritance, and this one is called virtual inheritance. That's why we have to introduce virtual table. Because the virtual inheritance, we're going to see virtual table. Okay, so that one is called multiple inheritance. That is called virtual inheritance. So whether you share one copy or two copies. Okay, so just clarify, if you talk about multiple inheritance in Python, this is the way Python. Python is actually doing this way in multiple inheritance. It's really confusing. So Python, I think they have a way to do that. Okay, they have a way to do that. Well, my argument is that as a programmer, if I want to do that, I don't have to do inheritance. If I account, I will do containment. I will define a new attribute called account that associated with the class employee. So in this sense, I can understand why Python doesn't even bother to actually do that. So that is two different ways. Okay, so one is called multiple inheritance. This is called virtual inheritance. Okay, so with this piece of code, so let me just syntactically help you to understand how do I actually specify multiple versus single inheritance. So if I have a code looks like this: work study, public employee, public student, and you can see that there's a nothing virtual in the whole code, then this is actually a multiple inheritance. On the other hand, if you have any virtual, virtual, which means the virtual actually appear here in the public relationship or appear here, or even you have a virtual function defined inside here, then you're going to do somewhat very different. You're going to have a virtual class. So let me show you the difference in terms of program. If I define this, you can see that there is no virtual. This is what we call multiple inheritance. If I do this, for example, I add a few virtual. If I say, hey, employee public virtual account, and the class student virtual account, then I'm actually having this picture. Okay, they're basically, when I specify virtual, that means they're going to share the same instance of account. All right, so this is called virtual inheritance, and that's called public inheritance. Okay, so when should you use a virtual inheritance, or when should you use multiple inheritance? It is something which is okay. Let me ask you a question. How can you actually say something under what situation you should use a virtual inheritance? And under what situation you should use multiple inheritance? Okay, if you ask me, I actually said that it's probably even in one of my recorded video. My answer to this question is that I will not use any type of multiple inheritance unless it is strictly necessary. If you look at my code, if you look at the code in the master directory of ecs36b, there is no single multiple inheritance. There's no single multiple inheritance. So when I define multiple inheritance, it means that I have one class that's simultaneously inheriting from both bases, more than one basis. I never done that in the code. The reason is multiple inheritance. Okay, first you have to understand the difference between these two. And it's really confusing because when you have, regardless of this, when you think about the concept, when I want to do something with work study, this is actually very easy to make an error because when you want to do something, you need to determine and control whether you are now behaving as an employee or you want to behaving as a student. Essentially, that's what they're doing. Multiple inheritance is that at a certain point when you want to expose the behavior of this multiple inheriting class, then the object has to decide at a certain point, I want to behave more like an employee or more like a student. And that is basically conceptually very difficult concept. Just think about the concept. So usually I realize that I don't need to define the class looks like this. I have other ways to handle the case I want to handle. So I always use single inheritance, and I do use a virtual function. A single inheritance virtual function is already pretty much take care of everything I want. Okay, I can probably spend multiple lectures to argue the case, the challenge about using multiple inheritance to do some of the things you would like to do. So which is why a language called Java, they actually don't have multiple inheritance at all. So Java has something else as a feature that you can actually provide the programmer as a way to represent the situation they would have been using multiple inheritance. Okay, so let me just tell you that multiple inheritance, that's why I'm actually putting the last lecture, because I feel this lecture is something which I'm going to teach you something I don't encourage you to use in your programming. I mean, just I said it explicitly. I kind of see the problem. I mean, the benefit of using multiple inheritance is way smaller than the potential problem you can introduce. That's basically my very biased opinion over this feature called multiple inheritance. So I feel that this is really knowledge to let you know, and this will lead to the idea of how to implement virtual function. Okay. All right. So that is just talk about programming language. So now I'm actually going to tell you is that, okay, if I have this two different way, I'm going to ask you the next question. If I have this inheritance hierarchy, when I create an object from robot or I create an object from work study, it's exactly the same, okay? They're even the same because all of this are one variable. So if I create an object called robot. Let's use a robot as an example. Core, person, thing, robot. So my question to you is that how many objects I really need to create? Meaning that how many constructor I really need to create, right? Because in this picture, I will see there are 4 objects, right? In this hierarchy, because person and thing, they share 1 copy of core. Because I need a memory location to save the data with a core. What is a core? It's a double, which is a URL. Okay, so I need to have a 1 copy of URL, which is the core. And I need to have a 1 copy of a sequence number, which is a thing. I need 1 copy of person, which is S social security number. And then finally, I need 1 copy of robot, which is the robot number. So essentially, when I look at this picture, you should think about from the constructor perspective that you actually create 4 objects or 4 parts to form the big object based on this inheritance relationship. Okay, so 4 objects for this one. How about this one? Let me actually copy this a little bit over here. Let me copy this. Okay, so for this one, let me remove this one. I don't like this. So I have a core, core. I have a 2 core, by the way. And I have person. And I have thing. And then I have what we call robot, right? That's the way to do multiple inheritance with exactly the same example. Okay, so I have 5 objects or 5 parts of the object or sub-object. That's actually formed when you create an object called robot. So now let's actually, at the C or C++ programmer, we always look into the memory. So if you think about that, this is interesting because, let me actually make a copy. So if you look at the memory, I actually have a 5-piece of object or 5-piece of whatever unit of memory. Okay, I'm going to put it here. 1, 2, 3, 4, 5, whatever. Core 1, core 2. By the way, I'm going to distinguish because this core is core for P, and this one is core for thing. Okay, they're different core. In this picture, one is core for P, one is core for T. And then I have a robot. Okay, so now I'm going to actually talk about the concept of memory layout. So what do I mean by memory layout? Looks like this. I'm going to put a piece of memory. So you can imagine you have a piece of memory. Looks like this on your computer. Now I have to move these things here. Okay, now we're looking at the issue called memory layout. Memory layout is that, well, how will the programming language, the runtime environment, when you create an object, how they're going to arrange those 5 objects onto a particular location of a memory. Assuming this is maybe a low memory address, let's use an easier way to represent. Assuming this is okay, let me do this. Low memory address, and this is a high memory address. Usually when I talk operating system, usually it's the other way around. But for today, we're not doing ECS 150, so I'm going to use a reverse way. It probably is easier for you to see the issue. So the lower memory means that the address is lower. Higher memory means the memory address is higher. All right. So my question for you is that, well, this 5 piece of object has to put in somewhere. I can give you a hint. This 5 pieces is going to be contiguous. You're going to compact together. So now I want to ask you, what's the order about this 5 pieces if I put it here? Which one should go with the lowest memory? Which one do you think is going to be the lowest? Yeah. You think the robot? Okay, let's try to do that. I actually forget it, but oh, wait a minute. I have to do this. I have to send to back. Okay, good. So you think robot first. Okay, good. And then what's next? Okay, let's go. Let me give you a hint. This depending on whether the program in no, not this one. So when you public inheritance, because you go with thing first, okay? So thing will need to go first. So okay, let's go. Let's go thing. And what should be the next one? What should be the next one? Yes. Okay, you want to go person, fine. And then what should be the next? Anybody else? I'm sorry, you provide all the answers. Yeah, core T, okay. Okay, first core T, and then core P. Okay, good. So this is a one memory layout. Okay, I put 5 of them inside here, right? So if I create an object robot, my pointer, remember, is always on the first byte. So you have a pointer to a particular object, it's always the first byte. Okay, is this, you can think about, let me actually roll it down, write it down. Why I'm doing here. Okay, first. Okay, this one is going to be, I would say, robot star and object. Okay, so you have an object, and then the address of this is actually pointing to the first byte of the contiguous memory, right? Okay, is that good? That's now you see that we're starting seeing that pointer, multiple inheritance, memory layout, everything is together. Okay, so now I actually want to do one thing. Remember, one of the issue I talk about is called casting. So casting is casting up and casting down, right? So what is a casting? So I take this one, I do a casting, and assuming you have this already, I actually do this. This is called casting. Let me show it to you. This is the original one. I want to cast that to a person. Am I doing this okay? Let me actually put something in between, shape fill with some yellow. Okay, and I'm going to change the color. Okay, so what does casting is doing? So casting essentially, we talk about casting as a move up and down from the inheritance hierarchy as we talk about, but casting also is a way I can extract part of the inheritance classes out. So when I do person star, robot star object, I really extracting certain parts of the object robot, but I extract exactly the person part. Okay, so let me ask you this question in C. Okay, not in C++, ecs36b. When you do casting on a pointer or on whatever, do you actually really change the value of the pointer? Do you really change the address of the pointer? You don't. Okay, you don't. But now it might change. Let me tell you why. Because where is the par with the address person? It's actually here. So this one, if I do this, if I do a casting, I'm actually supposed to pointing to here. I'm supposed to pointing over here. Okay. Does that make sense? Because when I do casting, I try to extract the part of the person. And so I have to move the pointer because remember when you do casting from the programming language perspective, this is no longer a robot. It is actually a person object. So when I access, I will directly access to the person part. So that's why it has to be, looks like this. And this will be a trouble because why? Usually a person, if you look at the person object based on, what's your name? Benjamin. Based on what Benjamin is saying that it's a person object. So usually if you look at the person object should have a person and the core P. If I create only the person object, it should look like this, right? Memory layout should look like this. So when you're casting, it will pointing at a person, but I'm expecting the core P should be contiguous right after this person. So I want to arrange I mean, by the way, I thank you for your help, but I'm going to arrange this a little bit different. I'm going to arrange this a little bit different. I'm going to move this up a little bit, move this down a little bit. Okay, and then when you're casting, you actually move over here. Does that looks better? Because now you see that when I'm doing casting, if I'm robot, I'm top there. If I'm person, I'm here. But if I am thing, then I actually casting over here. Okay, so you can see that. So the memory layout affect whenever you do casting, because sometimes depending on how you cast, it's a move around this way or that way. Okay. Okay, so any question? So now you start have a feeling about the relationship between inheritance and the memory layout and the concept of casting we talk about. Because when you do casting, you really move along with a pointer over here. But actually, I want to tell you that this memory layout is incorrect for multiple inheritance. It should be okay, not necessarily incorrect. But I want to tell you the true one for multiple inheritance. Let me actually copy this. This is just the design. I'm not saying this is better or worse, but let me tell you, the design looks this way. The design is the real memory layout. Okay, I have to be careful because I always forgot. Okay, so core is here, and then thing, and then core P is here. Sorry. Core P is here, and then person is here, and robot is the last. Okay. So okay, I'm going to get rid of this. So in some sense, if I only look at the person, it's actually also reversed. So basically the base class in multiple inheritance always come first in memory layout. That's why I said you have to differentiate lower address with higher address. So it's always looked like this. So what does that mean? Means that if I do casting for person, let me get rid of this, okay? I don't need this here. If the casting for person, This is actually going to be pointing here. Sorry, let me make it smaller. Yeah, I'm happy this way. Okay, so basically when you do casting of a robot to person, it actually move pointer. Oh, sorry, I was wrong. Not here, but here. Because let me actually draw a boundary. So let you tell what that casting is really doing is actually include these two pieces here. So I'm going to get rid of this. No outline. Keep making mistake. Okay, here. No fill. Okay, so if you do a casting to a person, you actually move your pointer to the first byte of the core P. But this has a very important advantage is that when you're casting to a thing, you don't have to do any changes because casting of things was still pointing to the first byte. If you're casting to a thing, okay, and then you can casting to let me actually tell you this is even more interesting. You actually have to access to both core. So if you actually casting another one, you cast core in front of a thing, then essentially this is going to be pointing at the first byte over here. But however, if you core casting in front of the person, it will pointing at this byte. Okay, you see that there, maybe I just write it down so you understand the difference. If I do this over here, if I actually casting another core, then I'm going to do a line. Give me a line, please. I'm going to pointing at the first byte here. Okay, this sounds complicated, right? So you can see that the memory layout, it basically say, okay, because if think about compiler, okay, if you have a robot pointer that pointing to the first byte of the core T, because compiler know this is what? This is a robot. And the compiler will know because a robot has multiple inheritance of thing and the person. So compiler know the first few byte is going to be core T, and then core the thing, and then core P and person and robot. So the compiler will have the knowledge to find where each of the attribute, each of the element of the multiple inheritance. So if it's a robot, it's going to point the first byte of core T. If it's you're casting to be a thing, then the thing also go to the core T because the thing knows that you must have a core T component, then you have the thing component. But when you want to go to the things core, then still pointing the first. So this three pointer is going to pointing exactly the same location. So if you're casting up and down with the thing, the address will not change. But when you want to do casting related to the person, then you immediately shift down to this location. Okay, so essentially with multiple inheritance, you have a two possibility, either top or the bottom. Okay. Is that good? Okay, so let me actually try. How do you verify this? How do you actually verify? Before I talk about virtual inheritance, yeah, I still have half an hour. That's good. So let's try to verify if I actually draw the picture here, it looks okay or not. Okay, so let's actually look at the program. So I wrote a program to do MI. Oh, not this one. Test multiple inheritance all in one. Okay. So I have a core. I have a person to core. I have a thing to core. I have a robot. But first go to the thing, then to the person. Okay, now let's actually see how do I print it. Okay, so look at how I printed. I print for each of the 5 objects. The way I represent, you can actually represent the address of the variable associated with each of the objects. So first number is a robot number. This represents the robot, the address of the robot, and the address of the person. Sorry, this part is interesting. I take a robot, I casting into a person, and then I print the host URL, which is the core of related to person. And I actually print the robot that I casting with the thing, and then I go to the host URL. And then I print the address of the social security number, which is represent the person object. And then I represent the sequence number, which is represent the thing. So according to the map I showed you earlier, so we actually want to print it exactly like this order. So let's actually arrange the order. So the lowest memory address should be the thing. Okay, and then the next one should be thing, which is sequence number, if our hypothesis is correct. And then the next one is the core for person. And then is the person itself. Okay, I'm actually printing 5 memory address according to the PowerPoint slide I just showed you. So if I'm right about that memory map I showed you in the previous PowerPoint slide, then I should be able to see a ascending order in terms of their address. The smallest address is the first line, the highest address is the last line. Okay, let's try to compile this program. Let me see, do I need anything? This program, I probably can just use G++ minus std is equal to C++ 14, and then test mi all in one, and then I will do minus o tmi, okay? Oh, std doesn't work, so I have to go back to get rid of some of the stuff. Do I have ecs36b comment? I do have. Okay, good. Okay, so I basically compiled this program called TMI. Let's actually see how this TMI work. Okay, now you can see that it print 5 different addresses over here in hexadecimal. Have you seen that the address, in fact, monotonically increasing according to this 5? So, and if you look at carefully, the difference is always 8. Okay, because it's a double. Double is 8 byte. So the first address is pointing to whatever the core, and then to the person, thing, which is the sequence number 8 byte, and then another 8 byte, which is another double. This will pointing to the core for the person, and then with this is the person social security number, and finally is the robot, which is the robot number. Okay, so we verify by so I want you to learn this because it's important for you to understand the basic principle that with whatever casting you can actually find out how the memory of your object, either single or multiple inheritance, how they are going to be arranged. So this shows the multiple inheritance. I can actually arrange. So this kind of validate our hypothesis about this arrangement, about memory, okay? Any question with multiple inheritance? Okay, so let me summarize. One of the things, among other things I want to tell you is that whenever you do casting under multiple inheritance, it's actually moved to a location, which is a pointer, and then the subsequent code after the casting is treated as this portion is the new form, the object I casting into. So in this case, it's a person or thing or core, whatever you cast. So the memory arrangement must arrange the relevant information or relevant memory layout together, compact, such that you can do casting this way, okay? Okay, going once, going twice, no question for this? Yes, please.
Earlier when there was the other way that I thought it was, that when I said person or thing, you said thing gets casted first. In which case, why is it in here that thing is, or and thing has to be below robot? Then why is it in this case the orientation of the flips?
Okay, so okay, number one, I want to clarify the design that you provide is also correct, but just C++ didn't chose to follow that kind of style. Okay, so they chose to follow this style so they can find out all the information. By the way, the other design we had earlier, we can also do this the kind of similar style of casting. I can still arrange. Okay, so number two, I'm guessing your question, I'm not sure I catch correctly, is that the number one is that whether the base class should go first or derived class should go first. So your design is derived class go first and then base class go next. But in their design, the base always go first and then the derived. I guess that's one advantage, but I think it's very minor, is that when you do casting, a lot of them don't need to change. The address doesn't need to change. But if you flip, then any kind of casting you almost have to change. But the compiler, it's just compiler has to figure out how to change. But the order between thing and person is purely a choice about the order what you specify in the inheritance relationship. Because when you do multiple inheritance this way, let's look at this code here, that it's just follow this order, that the robot is public thing, public person. It's just because the thing keyword comes as the first base class. So the first base class will actually put early. I mean, if you have a 3, it's always follow the order. That's just a compiler. There's nothing especially good. You can do other ways you want, but essentially that's the way the compiler need to decide. So I wouldn't be surprised. By the way, there's another C++ compiler. They might arrange memory somewhat different. Okay, don't assume that. But aware that compiler has to make a decision like this. Okay. All right. Any question with multiple inheritance? Okay, good. Let's actually take a look at the virtual inheritance. So I want to go back, just let you know what is a virtual inheritance looks like. The virtual inheritance looks like this. Okay, so everything is exactly the same, but except I adding the keyword virtual. Adding the keyword virtual in this relationship means that the class person, is willing to share the base class core with other classes that they have a virtual. So meaning that I'm willing to share the core. So essentially you can see that the thing is also virtual to the core. So it means that when you have a 2 virtual, that means, okay, they're going to share the same instance of core. Okay, so that's what it really means. Okay, so now let's actually go back to the same diagram. Okay, this time is actually going to be tricky. Be honest with you. I'm actually having trouble to do the same kind of memory arrangement anymore. So let me actually copy it. Let me get rid of this part. And I want to copy this one. No, not this one, this one. Okay, now I'm actually having this part. Okay, fine. I'll leave you there. So number one, the things we must have is we only have one core, right? Because we don't have that anymore. We have a one core. We only have one core. And that core is going to be shared. Okay, so now I'm going to ask you, on one hand, I only have 4 objects to worry. I'm going to put 4 objects on the memory. So how do I actually put this? 4 pieces. How many you're helping here, Benjamin and other students? How do I actually rearrange this 4? This is tricky. Okay, by the way, to save the time, it's impossible for you to arrange. I mean, let's try to do that. If you do this, if you do the way we actually, wait a minute, this was not right. We say, by the way, this was our final answer, right? Core things, core person, robot, that's the way. But let's try to follow this. If I do this, I do core. Okay, if I do core share first, just following the same paradigm, and put the robot here, and put the thing here, and then put the person here, and then put the robot here. Okay, that's one way to do it, right? Following the same style. Core, share, thing, person, and robot. Okay, this is okay for robot because the compiler, if compiler know the memory layout, the compiler have no problem to access each of the element. Okay, and then for thing, it was okay because why? Because this part is a thing. Okay, now let me draw the picture. It's important when I draw this particular square. If you're casting to thing, then this is okay. Because if you look at those 2 blocks, it's still a thing, object, core, and the thing. But it's going to be a trouble for a person because the person, the relationship between person and the core associated the person has been separated. It's no longer consecutive. Okay, so this is not okay if you do a casting for person. In fact, if in this case, yeah, you can directly do, yeah, person, you can still do this, okay? So I have to flip side this. So I'm expecting you should have something looks like this. But no matter how you do it, you're going to either hurt. You're either going to hurt the thing or you're going to hurt the person if you share the same copy, right? I'm expecting this, but there is no way I can actually get out of this. If you rearrange, you cannot get things to right. So because you share, you have only one copy. So that means the virtual inheritance is really going to give us some trouble if I need to deal with the core. To do the share core, okay? I hope you understand the problem. So then what should be the right solution? What should be the right solution? Any idea? Okay. Okay. The idea is let's print out the address. Remember I showed you the address? We actually print for multiple inheritance. As a programmer, we don't know what it is. We print the address and see their order. Okay. So let's do this. Let's Let's go to the other program, which is, yeah, this one is correct. Okay, I'm going to do include ecs36b common. And then I'm going to print the address. I'm going to print robot number. I'm going to print URL. By the way, this two should be the same. The following two, because they share. I'm expecting the following two are the same. Okay, no matter how you casting to URL, they share, right? And then I actually print the social security number, sequence number. Okay, so you should have 4 different addresses. So we're actually thinking about 4 different addresses. Let's try to run this program. The VI and the VI. Okay, let's try to run this. Oh. Okay, so now I want your wisdoms. Let's look at the result. Okay, so first we actually check. These 2 addresses are the same. So that's good. That's based on our understanding. They do share. The 2 core is the same core, 7388. Okay, but now let's actually look at, I'm going to copy the address into those 4 objects. So the first one is what? The first one is robot. Let me actually see what's the first one. The first one we print is the robot, right? Let's go to the PowerPoint. Where's my PowerPoint here? Okay. So let me actually just copy this 4 to, I want to tell you this, new slide. Fine, I'm just giving you this one. Get rid of this. Get rid of this. Get rid of this. Okay. The first number is the robot. So now we can actually start seeing what's happening here. Okay. So I'm going to just write down this number, make it bigger. Okay, the core address looks like this. Let's look at the second address, which should be the oh, wait a minute, sorry. That's I make a mistake. The first is a robot, it's not core. So this is the address of the core. And the address of the robot is the second one. The core is the second one. I'm just keep saying something which I don't understand what I'm saying. Okay, hopefully you understand. You're smarter than me, okay? Okay, so this is, can I make this bigger? Okay, that is better. Make it a little bit bigger. Okay, so then let's look at the thing. The thing is, let me see, which one is the thing? The thing is, okay, the next one is person and then thing. Person and thing. SSN is the person. So the next, this one is person. This one is a person. And then this one is thing. The the last one is thing. Okay, I'm going to ask you to do me a favor. Can you actually tell me what's the order among this 4? Okay, so this is the 4 we just got, right? So now we have to arrange according to the address from the smaller to the largest. Let me actually move here. This was original one. This is what we like for you to arrange. So which one has the smallest address? Which one has a smaller address? Which one? The robot. Okay. The robot actually comes first, right? So this is already very different from, remember, this is what we do earlier with multiple inheritance. Multiple inheritance robot has the largest address, right? So this is already conflicting about what our understanding about the feature called virtual inheritance versus multiple inheritance. How can you have the same language? The multiple inheritance, the robot, the lowest element in the inheritance hierarchy has the largest not IP address, memory address, where the virtual inheritance, you have the highest address. This is already, you see that it's coming, is actually pretty bad. Okay, so what's next? After robot, which one is the next one? Person. Okay. Let me get rid of this. So it should be person and should be core. And then it should be thing, right? Does that looks right? 70, 80, 88, 98, right? That's older according to the address we compute. Does this make sense at all? Doesn't make sense. Okay, doesn't make sense. Okay. Have you noticed the difference? Is that what's the difference between the robot address and the person address? How many bytes? 16. This has a decimal, 16. So previously, each of the difference is, if you remember when we run this program, it's always 8, right? Yeah. If you run this program, the difference is always 8, has a decimal 8, okay? From here to here is 8, from here to here is 8, from here is 8. So and suddenly we have 16. But we know the information for us to keep the robot number is only 8 bytes. So let me tell you that this is a surprise if you first time see this arrangement. So essentially, there is another 8 byte between these two. So let's call it. I will call this one. Let me change the color first. Let me change to gray. Guess what? I'm actually going to say this is going to be. No, I got the wrong one. I actually want to use this one, filled in with gray. Okay, good. And this is a vTable pointer. Okay, I'm going to put vTable pointer over here and then put it here. And then with the core, between these two are 8 bytes, right? Between person and the core is 8 bytes. But again, between the core and the thing, there's another 8 bytes. That's because between this last two is also 16. So it's a vTable pointer. Okay. So if you look at the structure of the memory on my system, by the way, different system I have a slightly different. But what I have is this memory layout. We still have that 4 element because we have, but we also have the vTable pointer. That's actually pointing to something which I'm going to tell you later. Okay. So you have this design. Is that looks correct? Yeah, that's correct. vTable pointer over there, vTable pointer. Okay. So let me first at a high level, I don't know how much time do I have. Okay, I have 6 minutes. I better run quick. So essentially, this 2-par is one object. When you do casting, this 2-par is one object. And I have to get rid of this. And this part is another object. So the top rectangle that I bound there, it basically represents the person portion of the object. And this is basically, this lower rectangle represent the thing object. But why is a vTable pointer? Because both vTable pointer is pointing to the vTable, and from that vTable, they will obtain offset information for them to actually be able to access the core share. So vTable, you can think about, this is a point, vTable pointer means that it's pointing to a data structure, which is represent the per class information about that. So for person, that vTable is actually pointing to the person class vTable, which is the thing is pointing to the thing class. And they will actually provide information so they can actually access to where do I find the core object. So it's really accessing this is harder because if I want to access, if I do a casting, I essentially need to do casting to an online, to a runtime computation. Why is that? Because the compiler actually don't know what is a vTable. vTable is a data structure that's created at runtime. So therefore, if I do casting from a robot to a thing, I actually have to calculate where is that, from the thing actually to core share, from thing to, from robot actually know where thing is because they can actually calculate. The robot actually know you have a 2 vTable. So from robot casting the thing or robot casting the person, no problem, compiler can figure out. But from thing to casting or whatever you want to access the core, you have to use vTable. And that vTable is not available until runtime. The compiler only know this 8 byte represent vTable, but have no information. So that's why this design make to have a virtual, you always involve runtime because you need to access vTable, and then you have to do that. Okay. Any question? So if I have a time, I will actually ask you to, using whatever way I print out, to access the vTable pointer to really look at this. So I actually use a tool. I don't have time to show you the tool, but this tool will generate the memory layout for you. Let me actually show you VI all in. So this is the tool that's actually the compiler with a CC1 option. It will generate this, but look at the last one. The last one, you see that the by 0 is actually started to be a vTable pointer. Oh, by the way, I actually make one more mistake. You see that there are 3 vTable pointer, 1 vTable pointer here, and 1 vTable pointer here. Okay, so we have this. But okay, I forgot to actually really talk about this. But there is one more vTable pointer. It's actually over here. This is a vTable pointer that's for the robot. So this is if you're actually pointing to the object, you're actually pointing to the first byte of the vTable. That's what this memory layout is actually generating for you. Is starting with the byte 0 is a robot vTable pointer, if you look at here. And then it's a robot number, the content. And then the byte number 16 is actually vTable pointer for person. And then the content for vTable pointer here. And then you have the next one is going to be core. Core is here. Core doesn't have a vTable pointer. But then you have a thing, which first go with a things vTable pointer, and then go with sequence the content. Okay, so this is the memory layout. You can generate it by the compiler. So compiler don't know the content of vTable pointer, but the compiler has a knowledge about this memory layout. So you can actually check whether your understanding about the virtual inheritance or multiple inheritance. So that is really the memory layout for this. Okay. All right. So vTable. I have exactly 1 minute, so I'm going to tell you something which is I have to tell you. Remember the interview question I asked you. So this is the picture I really want to tell you. Is that whenever you have an object, you have a class object, you have a pointer to vTable. So because you have either you have a virtual function or virtual inheritance, you're going to have the memory of your object, each of the object created from this class, you're going to have the pointer to vTable. And the vTable has not only the information to pointing to the shared variable, it actually has a lot of virtual function pointer. You see that? How is a virtual function pointer is actually going to be done is at the time when you create the object, I'm actually going to set the vTable pointer according to the right vTable pointer with the right virtual function. So that's why when you create the object, say you create an object, you create an object as a robot. So at the time you create the object robot, you actually set the pointer to the vTable of robot. So later when you casting the robot object into thing or to person or to core, it doesn't matter. Your vTable pointer is still pointing to that robot class. So therefore, when you want to call a virtual function, you will actually go through the vTable to find out that particular function pointer that's associated with the virtual function is supposed to come out from the robot in that case. So that's why in this quarter, we use a lot of dump to JSON. And regardless, it's a virtual function, regardless how you cast your object, it's always moved down to what was the original class when the object was created. That's because that relationship has been set up through the vTable relationship. Okay, that's kind of a very short description about how vTable pointer is going to help us to determine everything at runtime. Okay, which I want you to know because you might be asked this kind of question during your interview. Okay, so if you want to know more about this, you can actually look at the. I don't think the chapter 14 gave a really in-depth to this. Stack Overflow might have a more extended answer to that. Okay, I mean, this is my last class. I should tell you that the textbook is good in general, but you need to dig yourself to go into something which is deeper and better. You actually need to write a small program like what I did to actually show your to show your knowledge, your understanding about this subject is really consistent with what you see in the program. Okay, all right, thank you. And I'm going to end it here and then I will follow up with whatever project or homework assignment number 4. Okay.